Okay, in this video, we will see how to write a complex number in the polar form. So the polar form means r times e to the I theta. And the r is called the modulus, or you can think of it as the radius. And then the theta is, we call it the argument, but then you can think of it as the angle. So the meaning, if you draw it in the geometric meaning for this is if you have any point in the complex plane, then you can form you can connect with the origin. This is the length r, and then the theta is defined. I guess in this situation it doesn't have to be just that. It can be, you can add and subtract 2k pi from this. It won't change where this point is, so then it won't change what the complex number is. So this theta, remember, it doesn't have to be unique. So let's look at some examples. So the first one, z equals 1 minus I. And by the way, the radius or the modulus r, algebraically, you have this very convenient formula, square root of sum of squares. So it's the real part and negative imaginary part. So that's square root of 2. Also, now if you want to find the theta, so you can do the I guess the tangent theta equals like y over x. But then I usually feel like much easier to do it this way. So I will plot the point in the complex plane with x coordinate, y coordinate. So 1, -1, which is this point, 1, -1. And then I just need to find out what theta or what angle this line corresponds to in the plane, right? So you can compute, this angle, for example. I guess it doesn't have to be, oriented. You can compute a negative angle. And this is a special case, which we know that this is pi over 4, right? Because if it's 1, -1, that means these two angles are the same. So that's pi over 4, but be careful, it should be, if you're going this way, then it's negative pi over 4. You can also go from here like all the way to here. That's still gonna be correct. So you get a different value. It's gonna be positive. I guess it's pi plus 3 pi over 4. That also works, but then you can just use the negative pi over 4. So we write it as z equals r e times I negative pi over 4. So that's our that's the polar form. So let's look at some more examples. Z equals negative square root of 3 plus I. Again, I'd like to draw the complex plane. Right, this is the real part, this is the imaginary part, which means it will be -3, +1. So negative square root of 3, +1. So probably like here. That's our point. And then connected with the origin, we know that this is, you can use the formula, or you can just do like a special right triangle and calculate what this length is, right? But either way, it's gonna be 2. And then to find the theta, well, we know this is 1. This is square root of 3. So then we know this is pi over 6, right? Which means if you want to start with this positive x-axis, then this angle is going to be 5 pi over 6, right? So that's going to be our theta. which means we write z as r e to the I 5 pi over 6. Okay, so that's still not too bad. I guess you have to be very fluent with the special tricks, and then just be careful with whether the angles are negative or positive. And I think that's all you need. And then let's do more examples. How about z equals -2? So again, you just find the point -2, right? -2 is here. So it's actually, if you think of real part, imaginary part, it's the point -2, 0. So then how do you describe the radius? Be careful, the radius is not, it has this geometric meaning, so the radius is +2, right? It's the length. And then, so this angle in radians is certainly just pi, so which means z equals 2 times ei times pi. That's the polar form. Maybe let's do one more. Z equals 1 plus I over 2. Again, I find it easier to just draw the picture, so that's 1/2, 1/2. So it's in the first quadrant, right? When x, y coordinates are equal, it's kind of split this 90 degrees, so that's a pi over 4. And this length is, well, since it's special trig, pi over 4, this is also pi over 4, which means it's kind of the ratio of the sides are 1 to 1 to square root of 2, which means if you know this length is 1 over 2, or this, you should just multiply by square root of 2 to get this length. So that's our r, this is our theta. So then z is equal to square root of 2 over 2 e to the I pi over 4. Okay, so I guess it's still kind of an easy class of problem, but then you can come up with your own comfortable way to do it. For example, maybe I should say, since this is like x plus yi, right? Where x, y are both 1/2. Another way you can compute the theta is to say, I know tangent theta equals y over x. In this case, it's 1/2 over 1/2, which is 1. So then you just need to find the theta such that the tangent is 1. So if you remember the tangent kind of picture, right? It's periodic, right? But we only care about this thing. And then this is pi over 2. Well, I guess it doesn't really help you much by drawing this picture, but I want to remind you the picture of the tangent looks like. So then you can kind of, let's say I draw this picture to verify this result. So if you know this is 1, then this corresponds to pi over 4. Okay, so I guess the important thing is to be familiar with the special tricks to be able to do these problems correctly.